Hello, once again. Welcome again. Now we will switch to mathematics. In the mathematics, we will be starting today the new chapter. Today is 28th of September. Alright. In the new chapter, I am going to do from your reduced syllabus, that is mensuration. It is in page number 294. Page number 294. This is your mensuration. This mensuration is not a new topic. We have done this in class 9. We will be taking three solids here: cylinder, cone, and sphere. Okay. If you look at the reduced syllabus for this ICSE 2021, you have got area and volume of solids. The three solids are there. I don't know what is reduced. Everything is there. Maybe some applications you will get only the area, surface area, volume. Okay. You will be getting the combination of solids will also be included. So we have got cylinder, cone, and sphere. Today I am going to start off with the cylinder. Okay. First I will concentrate on the cylinder. Cylinder, we know all, it's a three-dimensional figure. Suppose this is a plane figure, so from the plane figure you have got only two dimensions, the length and the breadth. Now but if I roll it up like this, now it becomes a solid figure, that is three-dimensional. So we have got one cylinder here. See, this is a cylinder, okay, it's a solid figure. So in this solid figure cylinder, the certain things you have to keep in mind. So if I draw it, it will be something like this. So here this is the two circular face. We have got radius, and here also we have got radius, and this is the height. So these are the two nomenclature you have to keep in mind in the cylinder. This cone and sphere will be doing in the next class. So today I'll just concentrate on the cylinder. Now if you see that this R is the radius and this h is the vertical height. So you have got only these two things in the cylinder. So now here in cylinder, I am not going to go in detail. I am just going to deduce or derive the formula for you directly. The deduction of the formula is not required, only the application of the formula. If you see that it has got surface area, so you have got two surface area in case of a cylinder. Surface area means this area of the surface. Okay, this is the surface. Like for example, you have a surface here. Suppose it is rolled up. So this is the surface. Whatever area. So you have got two surface areas here. The first one is called the curved surface area, which is CSA. Sometimes it is also called the lateral surface area. Lateral means the side. And the second one is the total surface area, so which is also known as TSA. So let us find the formula for the curved surface area. It is quite simple. The curved surface area is 2 pi RH. Yes, 2 pi RH is the curved surface area. So we have got here the curved surface area 2 pi RH, and all of you know that the pi is a constant whose value is given to you as 22 by 7. R is the radius. If you see that this is the one circular face, so here you have a circle, area of the circle, that is pi r square. Alright, here also you have got another circle, so you have got two circles in a cylinder. And this surface, when this surface is flattened out, it looks like a rectangle, and the area of the rectangle is the length into breadth. So I am not going to detail because it has been already discussed. Only you need to remember this curved surface area is 2 pi RH. And the second is the total surface area. In the total surface area, you take the curved surface area, okay, this on the side, plus the area of this face and the area of this face. These two faces are it is in circular, and we know that area of the circle is pi r square. So since there are two faces, so it will be 2 pi r square. Now 2 pi r you can take common, bracket open, h will be left here plus r will be left here. So we have got total surface area and curved surface area. Please remember this, pi is 22 by 7 or it will be 3.14. Sometimes the value of pi will be given to you in the question. If it is not given, then you have to use 22 by 7. It is a constant. So these are the two areas you will get for the cylinder. Now the third one is the volume. Volume is also known as the capacity. So how much volume, or what is the capacity to take the things inside this cylinder? So now basically if you look at the solid, the general formula for the volume of any solid, it may be a cylinder, it may be a cuboid, it may be a cone, it may be a sphere, etc., etc. The volume is always found as the area of the base into the height. If you look at here, what is the area of the base? It is a circle. So volume is given as pi r square. You take only one base into what is the height? The h. So therefore, the volume of the cylinder is pi r square h. So this becomes your formula for the cylinder. In the cylinder, these three formulas are very, very important. The radius you have to keep in mind. If sometimes in place of radius you will be given the diameter. The diameter is the double of the radius. If diameter is given, then you divide by 2, then you will get the radius. Then height is there, it will be a vertical height. So these three formulas are very, very important in terms of a cylinder. Okay, so now we have got two other solids, that is the cone and the what do you call, the third one is sphere. So let me discuss that cone also quickly to you, because the cone and the cylinder are very, very similar. Cone. So for the cone I did not find any object here. So basically cone is it is same as a cylinder, only one of the circle is removed, it has been slanting, so it is pointed somewhat, it looks like this. You have seen that birthday cap, etc., that is somewhat similar to the cone. Okay, so this is a cone here. So basically in the cone also there will be only one base. See, this base remains intact, the height also is remaining intact. Okay, but what is the difference you find? This is it has been squeezed because the area, the circle at the top is removed, it is reduced to a point, so it goes and it becomes a slanting and it goes and meet here. So you will find one height here, that is the new thing in the cone, that is called slant height, because it has been slanting and it meets at a point. So in case of a cylinder you have got only radius and the height, but in the cone one new nomenclature is added, which is known as the slanting height. So r will be your radius, h will be your vertical height, and L will be your slanting height. Now for example, if you only concentrate on this figure, and you suppose you take it as a triangle, two-dimensional figure, so it will resemble the right angle triangle. So in the right angle triangle, this is looking like a hypotenuse, this is looking like a base, and this is looking like a perpendicular. So from the Pythagoras theorem, here also we can apply this relation L square equals to h square plus r square. Now this is one extra relation which is very, very useful, because in some of the questions any two sides will be given, then with the help of this relation we can find the third side, because sometimes the height and the radius is given, then you need to know the slanting height. Then use this equation. From there you find the value of L, the slanting height. So in the cone also, it looks something like this, alright. In the cone also we have got three formulas like curved surface area, total surface area and the volume. So it is basically same. So you just have to take 1/3 of the cone. Alright. So let us take what is the curved surface area for cone. The curved surface area for cone is given as pi RL. Okay, let me rub the cylinder here. We will be only focusing on the cone here. So this is for the cone. So we have got curved surface area. I am writing in short form. The curved surface area of a cone is given as pi RL. Now here it is cut into 1/3. So you should not be focusing too much on this how it came. There is a long process to explain, and that is not required also when you go to the higher classes. If you take up, let us say, mathematics, then you will come to know how this formula actually came or it arrived. The second formula is the total surface area, TSA. So in the TSA we take the curved surface area, which is pi RL. See here, it is like this. Curved surface area is only for the surface. Okay, so since we have a slanting height here, L, so we are taking it as pi RL, and in the cone there is only one circle, one base. So plus the circle is pi R square. So from here, the total surface area is pi R, you can take common, L plus R. So this will be your total surface area. Likewise, we have got the volume. Now since the cylinder, we have just learned the volume of the cylinder is pi R square H. So in the cone, what happens is one of the circle has been taken out, it is reduced to a point, so it is squeezed. So therefore 1/3 it is taken out. So therefore the volume of the cone will be 1/3 of pi R square H. See, volume of the cylinder is also pi R square H. Just add 1/3, that will be the volume of the cone. So we have got these two solids, cylinder and the cone. We have derived or deduced the three formulas for the cylinder and three formulas for the cone. Now the third solid is left, which is sphere, which is altogether different. It is something like a football. In the sphere you don't have a height, basically you have a diameter which is taken as the height. Then you have only one surface in the sphere. So that we will discuss in the next class. But for the time being, the cylinder and the cone you have to learn it, and we will be solving the exercises, all the ICS exercises in the next class. Thank you very much. Please learn all the formulas of this cone and the cylinder. Okay, see you.